Okay, you can go.
Hi, this is our Science AA, we're Group 10. I'm Songkiat, this is Kim Long, Daniel, and Brian. So our choice for the indoor learning space is the library, as it is not environmentally friendly, is unsustainable, and might cause health issues.
So the problem we found is that the library is not very well ventilated and is in need of a filtration system. And sometimes during the cleaning of the lid in the school, the chlorine gas will find its way into the library and will stay for a long period of time due to the poor ventilation and lack of air filtration. The fumes are very intoxicating and can cause lung damage and thus impact the efficiency of students. The solution we found is that an air filter can be installed to filter out radon-sized particles, as it can filter out particulate up to 150 picometers, and chlorine gas, which are bonded using two chlorine atoms, have a length of 198 picometers. And additionally, the filtration system also can function bidirectionally and purify both incoming and outgoing air to maintain indoor air quality and thus maximize the efficiency of students.
So the second problem is that the library's air conditioning is always turned on in order to make the library cool so that students can be more productive and comfortable. However, this is not environmentally friendly because air conditioning uses a lot of energy to operate, especially in hot climates such as Singapore. The electricity comes from fossil fuel sources such as coal or natural gas, which releases greenhouse gases when burned. In Singapore, more energy is required to run air conditioning due to the hot climate, hence leading to higher emissions of carbon dioxide and other greenhouse gases. The solution is that polyethylene can be filled with nanopores to form aerogel. When the aerogel is layered on infrared transparent coatings, the nanopores within the aerogel scatter incoming light due to the mismatch in refractive index between the air in the pores and the polyethylene material. This scattering of light causes majority of the sunlight to be reflected away from the walls. Polyethylene is also naturally transparent to infrared radiation, which means that it allows heat from the library to be emitted. When the aerogel with nanopores is layered on infrared transparent coatings, it allows thermal radiation from the library's walls to escape, passively cooling down the library. Furthermore, aerogels are good thermal insulators. They have very low thermal conductivity, and as the air in the nanopores cannot effectively conduct heat due to the Brunstern heat effect, where the mean free path of the air molecules is comparable to the size of the pores. This means that heat from the outside of the library cannot easily penetrate through the aerogel, allowing the air conditioning to be turned off or turned down during times when it is relatively cool outside.
So moving on to the next problem, school libraries often contain various pollutants such as dust, mold spores, volatile organic compounds from furniture and building materials, and allergens. Poor indoor air quality can contribute to respiratory problems, allergies, and other health issues among students and staff. This causes a negative impact on people when they use the library. So our solution would be to introduce indoor plants known for their air purifying properties, such as spider plants, snake plants, peace lilies, and pothos, which can improve air quality. These plants absorb pollutants such as formaldehyde, benzene, and VOCs, thereby enhancing indoor air quality and creating a healthier environment for students and staff. So the indoor plant is represented by a snake plant is represented by the plant in the video.
So the next problem that we have is that there's moisture buildup in school libraries, especially in areas with high humidity levels, and this can promote microbial growth, such as mold and mildew. Mold exposure can trigger allergies and respiratory problems in sensitive individuals. Our first solution to this is that we can introduce natural biological agents, such as certain species of bacteria and fungi that compete with mold can help control its growth. For instance, introducing non-pathogenic strains of bacteria and fungi that feed on mold spores can effectively inhibit mold growth. Additionally, ensuring proper ventilation and maintaining optimal humidity levels can create an environment less conducive to mold proliferation. Our next solution is that some of these bacteria can produce lytic enzymes that can degrade fungal cell walls, including those of mold spores. By breaking down fungal structures, they can effectively control mold growth in the environment. And that is all we have. Thank you.
Thank you.